is this going to work? Yeah, there we go. Oh, hey guys. All right, so we are going to 1-0 today, which is about understanding scientific notation. So we're going to kind of extend what we were doing when we were talking about powers of 10 the other day. And yeah, rather than rounding it down to the largest place value, we'll probably take it down to like 2 or 3 digits today, or 2 or 3 decimal places. So we got this maniac right here. He's got this really, really, really kind of crazy long irrational number right here. So we're going to convert this into scientific notation. So scientists often write very large or very small numbers using exponents. How might a scientist write a number shown, or write the number shown using exponents? So let's see. We'll kind of cut it off here. If you can see that at that 274, right? So what we're going to do is we're going to move the decimal. Let me just write it out here so it's a little easier to see. Let's see, 4 zeros, 2, 3, 4, and then 274. Okay, so the idea here is you move the decimal point. He's so zoomed out. Basically, right after the first non-zero digit. Right, so this 2 is the first non-zero digit. So we go 1, 2, 3, 4, 5. So we moved its 5 spaces to the right, right? And we already know that since this is below 0 and we're moving to the right, then we're going to have a negative exponent. Okay, and that exponent, the value of that exponent is going to be that 5 right there, right? It's technically going to be a negative 5. So let me take this 2, and we can actually just do this, 2.74, and then we multiply it times 10 to the 5, but we got to make sure it is negative. So we can rewrite that super crazy long number. Actually, shoot, we should round that to 5 at the end right there, sorry. That should be 275. So our end result should be 2.75 times 10 to the negative 5. Yeah. So that's the only thing I would change there. Yeah, you basically just count how many spaces you move it. 1, 2, 3, 4, 5. You just look for the first non-zero digit and kind of move it to the right. And again, this is if you have a very small number that is less than 1. So you have a negative exponent. Not too crazy. Louisa is researching the approximate distance between Earth and the Sun. Her father told her the distance is 9.296 times 10 to the 7th miles. An astronomy book stated that the Sun is, focus up, 92,960,000 miles away, which we've got right here, and we've got right here. So we're just going to kind of compare these to see what we got. So I think it's easier to convert from standard form to scientific notation rather than converting from scientific notation to standard form. We will do that in a bit. But for right now, I'm going to take this 92 million, convert it into scientific notation, and see if it matches the number that her father told her, right? So when it's a very big number, we move it to the left. 1, 2, 3, 4, 5, 6, 7. We don't really need to worry about rounding this. We'll kind of just cut it off right there. So let's see. I forgot how far I moved it. 1, 2, 3, 4, 5, 6, 7. So we moved it 7 spaces. Okay. And again, it's to the left. And it's a big number. So we're going to use a positive exponent. Okay. So 7, right? We can already kind of see that this is going to match up, right? So this is going to be that 9 point. The decimal goes right there after the kind of to the right of the first number. And then 296 times 10, and then that exponent is 10 to the 7th. So they are both correct because it works out to be the exact same number. Yeah. So write small numbers in scientific notation. What is the width of a red blood cell? Written in scientific notation. Red blood cell is a very small number. So we know we're going to be going to the right, so it's going to be a negative exponent, right? It is less than 1. So let's see, I'm just going to rewrite it. Let's see, 1, 2, 3, 4, 5 zeros, 703. Okay. So I move it 1, 2, 3, 4, 5, 6 spaces to the right. Okay. So 6 spaces to the right. I know it's going to be a negative exponent because it's a small number. So we take that 7.03 times 10 to the, what was it, 7? I keep forgetting. 1, 2, 3, 4, 5, 6. So 7.03 times 10 to the negative 6. Let's count again. Make sure 1, 2, 3, 4, 5, 6. Yeah. So yeah, it's a very small number right there, 7.03 times 10 to the negative 6. It's just a different way to write numbers, guys. That is the entire purpose of scientific notation. Yeah, it's just a different way to write very large, very small numbers. It allows you to compare things and figure out how much bigger or smaller something is than another very easily. Yeah, because you're basically just comparing the exponents. Right? But yeah, so that's the idea here. So now we're going to kind of reverse the process. We're going to convert scientific notation to standard form. So when you use a calculator, like a scientific calculator, when you use when you have a very, very big number, it will typically display it like this, where it's like 3.5 and then E15. That E stands for the exponent of the power of 10, right? So if I were to write this out, that 3.5, E15, right? That's what it looks like. Right, 3.5 times 10 to the 15. Very easy to tell. It just doesn't, because it's a calculator, it doesn't really want to write that 3.5 times 10 to the 15th, right? So it just says E, standing for exponent, and that exponent is just the exponent of the power of 10. So we want to write this in standard form. Standard form is just regular numbers, right? So it's going to have a lot of zeros, right? We know it's going to have 15. It's going to have 15 spaces for this 3.5, right? So we write this 3.5 right here, and then this 5 right here, since it's kind of to the right of the decimal place, that actually counts as one of those 15, right? So we write, we've got this 5, and then we actually do 14 more zeros, because this 5 counts as one of those spaces, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now, when you have a very long number like this, you have to make sure to separate it with commas, right? So to figure out where to put the commas are, you always start at the right side and you just count 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So let's see, that's thousands, millions, billions, trillions. So that's 350 trillion, whatever, right? Doesn't have units, so it's just 350 trillion. Yeah, so that's the same thing, right? So then we've got this 8e negative 9, so we can see the difference here, this e15 and this e to the negative 9. This is a very big number. This is a very small number because it's negative, okay? So I'm going to start with the 8, right? And that decimal's right here. And now we're going to move it over like 9 spaces to the left, okay? Like go this way and basically put the zeros over here. Okay, so let's figure this out. So we've got it here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So just like that. So we've got, let's see, if I move it over, it should be 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly. Okay, cool. So let me rewrite it so it's a little prettier. We got 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, right? So 8 zeros. And that 8 right there is that kind of 9th space that you move it, right? So let's see, 1, 2, 3, 4, 5, 6, 7, 8, and then 8 on the end. So that gives us our answer right there. Yeah, that's how you do it. So write these numbers, try these on your own, come check back in a few minutes. Check back for a few minutes. Check back when you're done and just press play because it's a video, right? This isn't in real time for you guys. Okay, so we got 18 zeros right here, 18 spaces technically, because these aren't zeros, but they are spaces, right? So I have this 9, 2, 2, 5, and I need 15 more basically. So you know, 1, 2, 3, and then to get to 18 spaces, I need 15 more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So then put your commas in every 3 spaces. Good Lord, thousands, millions, billions, trillions, quadrillions, quintillions. So 9 quintillion, 225 quadrillion, whatever it is. I don't know, some sort of distance in space maybe, or number of bacteria or something. All right, so I've got this 6.3 and this 10 to the negative 8. So I'm just going to put it over here so I have enough space here. So 6, 3, and my decimal is right here, so I'm going to move it 8 spaces. So 1, 2, 3, 4, 5, 6, 7, and then 8 right there, and that's my decimal. So let's see. Let's double check. So I need to move it 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Okay. So I'll rewrite it. 0 point, and then 1, 2, 3, 4. Let's see. 1, 2, 3, 4, 5, 6, 7. Yeah. 1, 2, 3, 4, 5, 6, 7. I just figured out an easier way to do this. It's going to be 7 zeros because this counts as that 8th space. So 6, 3, and then 7 zeros, and then that's it. So that's actually an easier way to do it than what I was showing you. Too bad I figured it out at the end. Anyway, this key concept just gets together exactly what we were talking about, right? Scientific notation is a way to write very large or very small numbers. Scientists use them as a more efficient and convenient way of writing such big numbers. So when you are converting from standard form to scientific notation, you move it to the right 7 digits, 7 spaces, and that's your exponent. And then yeah, same thing, right? But kind of the opposite. We moved it 5 digits that way, so that's where that negative 5 comes from. To write a number in scientific notation in standard form, multiply the decimal number by the power of 10. So yeah, that kind of just summarizes it all right there, exactly what we just did. So take that, fold it in half right there. Ooh, that's a weird color. I'm going to put this in our notebook. That's like on page 16 or something. I don't know. Let's see. 15, 14, 15. Yeah. So this will be on page 16 for me. It'll be understanding scientific notation. Or just understand, because that's what it says on the top of my notes. So understand scientific notation. And again, what I'm writing right here, this is exactly what goes in the table of contents, right? I just mash it up like that, right? Because that's how the table of contents should work. It should match up exactly. Okay, move that in. I'll put that in the table of contents as well. Okay. Okay, table of contents, page 16, 1-9, understand scientific notation. There you go, guys. Hope you enjoyed.